Welcome everybody, thank you for joining us. This session is called ArcGIS Runtime SDK for Qt, Building Apps. My name is Lucas Danziger, I'm the product owner for the Runtime SDK for Qt, and I'm joined by my colleague Jared Kakamo. He's a product engineer on the team. So today we're going to be talking about how to build apps with the Runtime SDK for Qt. So we'll start by talking about what Qt is, so anyone unfamiliar. We'll learn about the Qt framework, what it can do, why it's so powerful. Next, we'll talk about the Runtime SDK for Qt, some of the capabilities, workflows that you can achieve with this SDK. Next, we'll talk about how to get started. So this includes the installation steps, all the way up to building your first application. Next, we'll talk about fundamental development patterns, so some of the key coding paradigms that you'll need to understand when working with the SDK. Next, we'll talk about how ESRI uses Qt. And finally, we'll talk about where to go from here, how you can get started. So what is Qt? Qt is a set of cross-platform libraries for native app development. There's two key concepts I want to highlight there. Cross-platform, meaning you write your application once and it can run on many different platforms. The other being native apps, and this is in comparison to web apps. Native apps run natively on the device. Web apps run within browsers. So when you run natively on the device, you can do some things that browser-based applications cannot do. You can access your local storage, your camera, your Bluetooth, GPS receivers, all these things that you associate with native apps that you get from the store, the App Store, the Google Play Store. These are all native applications. With Qt, your business logic is written in C++, and then your UI is written in QML, which is a JavaScript-based language developed by the Qt company. The Qt company is the company that maintains the Qt project. Qt's mantra is write once, deploy everywhere. So the idea is you write your application code one time, and then you simply build using the different compilers for Linux, Windows, Mac, iOS, and Android. This requires no code changes when you're going between these different platforms. All of the platform nuances are abstracted from you, so you don't need to understand platform-specific concepts. So things like Android activities, those are not important to understand when you're building Qt applications that run on Android. Qt provides abstraction APIs for common workflows, so things like making HTTP requests, working with local data, sensors like your gyroscope or Bluetooth sensors, working with your current position. All of these things, there's one API that you code against, the abstracted API, and then Qt does all the plumbing work for you to work into the individual platforms to expose that capability. So more specifically, which platforms can you build for? With our SDK, we support Windows, 64 and 32-bit, Linux, 64-bit, Mac, 64-bit, Android, we support ARMv7 and ARMv8, which are the 32 and 64-bit versions for devices, and then x86 is useful for emulators. In iOS, we support ARM64 as well as the simulator for testing. All right, so how does all this work? Well, like we talked about, we have our different platforms: Android, iOS, Mac, Linux, Windows. So if you were to seek out writing a native application for each of these platforms individually, there's many things you'll need to consider. There's different languages, there's different platform APIs, there's different compilers that you'll need to know about. But with Qt, they expose this abstracted API like I've been talking about. So something like Q Network Manager handles all of the network requests for you. And the C++ code can call into all of these different languages and make the requests necessary. On top of the abstraction APIs, we have additional Qt GUI libraries, so things like combo boxes and buttons and charts and images, all of these things to make rich user experiences and user interfaces in your applications. Qt gives you libraries for this as well. and your application sits at the top of all of this. So what are some of the capabilities of the Runtime SDK for Qt? First, we support offline maps and scenes. So we support creating mobile map packages and mobile scene packages in Pro and then consuming those in Runtime. We also support publishing maps as web maps and then taking that map offline either on demand or in a pre-planned fashion. We support offline routing, offline geocoding, offline geometry analysis, so things like checking if geometries intersect with each other, if they're overlapping, and so on. We support symbolizing and using custom renderers, so things like dictionary renderers for military symbols, really complex symbols you can publish in Pro and share as style files and open those in Runtime. We support geoprocessing. We support searching, identifying, querying, displaying pop-ups. We support working with ArcGIS Online and Portal. We support your ArcGIS identity, so logging into these different systems using the different security measures, whether it be IWA, OAuth, PKI, token. We support the utility network for doing electric and gas traces. We support navigation, augmented reality, so displaying your 3D data in an augmented reality scene. And of course, last but not least, we support data collection and editing. So next, we're going to have Jared display some of the Runtime SDK for Qt capabilities for you using our sample viewer application that comes with the SDK.
Yeah, so like Lucas said, my name is Jared Kakamo. I am a product engineer for the ArcGIS Runtime SDK for Qt team. We're going to go over some samples to try and cover a wide breadth of the capabilities of the ArcGIS Runtime platform. Those capabilities being maps, scenes, which is 3D, layers and data, services, offline, styles and visualizations, query and edit, route and directions, spatial and data analysis, and utility networks. It sounds like a lot. We're probably not going to find a sample for each and every one of these because that would take too long, but I'm going to try and pick a few that covers the majority of these. And if you're interested in something that I happen to not discuss here, I would highly encourage you in either case to go and check out these sample viewers after this presentation. They are made available through the SDK installation. So if you install the ArcGIS Runtime SDK for Qt, you'll get both the QML and C++ sample viewer installed with it if you would like. You can also find these on ArcGIS Online and download them there. And we also have the public repository on GitHub for you to check out these samples, and you can run them individually rather than through the sample viewer. So first, we're going to take a look at the identify layer sample, just kind of get our feet wet. We have two layers in this particular example. We have a map image layer, which is what's showing us the sample world cities, which are these blue dots. You click on them. There's one feature where I click, you can do an identify on the map view and get some information back from that layer, which has been identified. And even in a case where there's multiple layers on top where you click, you also get both layers, how many features are underneath, and you can interrogate those and do what you want with them and provide some information back. So pretty simple. Then to just do a little high-level overview of the sample viewer itself. So currently we're looking at the live sample view. We also have a source code view, which will let you see the source code files of the individual sample that you're looking at, QML of the UI, and then the class implementation file. We also have a description, which is just kind of a high-level overview of what to expect from the sample, how it works, a use case, about the data, information like that. And then we also have a link to our API reference, which will take you to developers.arcgis.com and our API reference. I'm not going to click on that right now because it is not part of what I'm trying to do here. So let's go into the next sample, which is going to be viewpoint cloud data offline. I'm going to go to the live sample view. This point cloud layer is contained within a scene layer package. Scene layer packages contain a cache of building, multi-patch point, or point cloud data sets. Scene layer packages can also be published as web scene layers to ArcGIS Online or ArcGIS Enterprise. Point cloud layers are really great for large volumes of symbolized and filtered point cloud data, as we can see here. They are optimized for the display and sharing of many kinds of sensor data, such as LiDAR. So in this case, we're actually seeing, we're given a color value dependent on the distance it took for the sensor to send that data and receive it back. And the shorter the distance traveled, the more intense the red, and the further the distance is with the lighter colors, the cooler colors. And you can see it actually paints a pretty clear 3D picture of this area. And this is all done in a singular package, which can be taken offline, but pretty neat sample. So the next one we're going to take a quick look at is the mobile map search and route sample. Go to the San Francisco package, and the third one is we're going to be looking at. So in this case, we've loaded a mobile map package which has been downloaded prior to this, just to keep the sample moving, this demo moving smoothly. What makes mobile map packages so powerful is that they make it easy to contain within the many necessary components of a map. But in an offline setting, as we can see, we just have this map. And such things as a transportation network for routing and navigation, which is what I'm going to illustrate in this particular sample. We also have locators for address searching or geocoding, which we'll be doing in a later demo today. And then we also have maps, like what we see. So in this case, I've placed 3 points. I'm going to click on the top right, which is to route. And then we have a route generated. And even though we don't have directions shown on this one, we have directions shown on other samples, but you could easily get the directions back within this particular sample by requesting directions, and you could display them in the list view. And all done in an offline setting, which is pretty good. The last one we're going to take a quick look at is the edit features with feature linked annotation. This one, we actually download a geodatabase, and it has an annotation layer, which is feature linked, as the title would suggest. So it's pulling from these features the address name and the street name. And since it's feature linked, we're actually able to edit these attributes and update them, and they'll persist to the local geodatabase that we've downloaded, including relocating the geometry. And we can also move this polyline or this line to a different location. And what makes annotation so useful is when you want to, when you don't want to move or resize text when the map is zoom or panned, as we can see here, you just want it to be static. Whereas with labels, they would resize and move. So this is the last sample I will be showing for this first demonstration. If I didn't cover one of the capabilities that you're interested in, feel free to reach out at the end of the presentation, or I'd highly encourage you to go check out either of our sample viewers, the QML or C++ on arcgisonline.com, or through the SDK installation itself, or you can check out the public repository on GitHub and check out the individual samples there.
So next we're going to talk about how to get started. The first thing you'll need to do is set up Qt. You'll first need to create an account. So Qt's website is qt.io. Next, you'll need to determine if you need a commercial license or an open source license. Their website has documentation on what you will need depending on who you're deploying to and if you'll make revenue from the application or not. You'll next need to install the different kits for the target platforms. So for example, if you want to build for iOS, you'll need to have a Mac and install the iOS kit. If you need to build for Windows, you'll need to have a Windows device, and then you'll need to install the Windows kits. You'll also need to install the IDE Qt Creator, which is the primary IDE for Qt development. It is possible to use Visual Studio, but we recommend Qt Creator because it works best out of the box. Next, you'll need to install the different compilers and SDK dependencies. So for Mac, you'll need the Xcode compiler. iOS as well will require Xcode. Windows, you'll need the Visual Studio C++ compiler, as well as debugging tools. Linux will require GCC, and Android will require you to install the Android NDK and the Android SDK. Once you have all of the dependencies set up, you can now install the Runtime SDK for Qt. So the first thing you'll need to do is, if you haven't already, create a developer account on developers.arcgis.com. Next, you'll download and install the SDK. We have a nice install and setup guide linked on the right side here. And finally, you'll need to get an API key from the website, and you can begin building your first application. When you're building a Qt app, there are three main different patterns you can follow. The first is QML with Qt Quick. This uses our QML API. This is a great place to start if you're a web developer because it requires no C++ skills at all. QML, like I mentioned earlier, is JavaScript-based language, so it's very familiar for web developers, and this runs on all platforms. The next pattern is the most commonly used pattern, so this is C++ with Qt Quick. So Qt Quick is the UI framework, but you'll use C++ API for the business logic. This is great for C++ developers. It runs on all platforms as well. The nice thing is that you can write your UI in QML here, but your backend in C++. Finally, we have C++ with Qt Widgets. So Qt Widgets is a different UI framework provided by Qt. This is more of a robust legacy desktop framework. So it's purely C++. There's no QML involved. This is great for C++ developers that only want to target desktops. It doesn't work well with touchscreens. It doesn't work well or at all on mobile devices. So this is great for those really heavy desktop applications. So let's talk about the QML API a little bit more. QML is a declarative language from the Qt company. Declarative means that you describe your components. So instead of controlling the flow and exactly how things get initialized and in what order, you simply declare components with their properties, and then the engine will figure out how to resolve everything properly. You can see with the code snippet that it's very similar to JSON or CSS. QML makes heavy use of a concept called property binding, and this is where you have your property name on the left-hand side with a colon in the middle, and on the right-hand side you have an expression. So you can simply bind one property to another property, for example. So this makes it really nice because you don't have to control the flow of everything. When one thing gets updated, it will trigger anything that is bound to it to be updated as well. This is done through Qt's notification system. If you need to, you do have the ability to write procedural code as JavaScript functions. So for example, when the user clicks on a button or clicks on the map, you might have some procedural code that you want to execute. You can do that through JavaScript. You can create your UIs very rapidly with Qt Quick. There's animations and pre-built controls, so it's really easy to get an application up and running very quickly. The QML API is the API used by App Studio. So for anyone out there that's interested in App Studio and the different tools and templates that they have available, this is all making heavy use of the language QML and also the runtime QML API. Next, I'll talk about the C++ API. With the C++ API, it's very flexible because you can create your UI with Qt Quick or Qt Widgets. So like I mentioned earlier, Qt Widgets, if you have really specific desktop needs, some components that are really fine-tuned for desktops, you'll probably need to use widgets for that. But for more cross-platform applications that run on mobile platforms, Qt Quick is the way to go. It's a modern C++ API, so using things like smart pointers, auto keyword, lambdas, all of those good new language features are supported with our API. You get really great performance with C++, and you also get access to the local server SDK. Local server is a separate installation. This gives you the ability to run local geoprocessing packages from ArcGIS Pro, so it really extends the power of desktop and brings it to your clients via the local server. At the bottom here, I have a link for you to learn more about the differences between C++ and QML and help you make the decision about which API you should use. So next we're going to have Jared talk to you about how to build your first ArcGIS Runtime application by using the new project templates.
So the first thing that you are going to need to do in order to build your first app is to create a developer account and get your API key. In this case, I've already created my developer account, just like creating any other free account. So we're going to sign in, and you'll get placed immediately to your dashboard, and you'll notice that you don't have any API keys. So we're going to create our first API key. And this is how you access online base maps, locating, things like that. We're going to give it a name, a description, create the API key. Now we're going to copy this key and hold on to it for later. So now we're going to be moving back to Qt Creator, and let's go to Qt Creator. We're going to go to New. And once you've installed the ArcGIS Runtime SDK for Qt, and you run the post install, the post installer will place these templates in your Qt's wizard folder. So every time you load Qt Creator, it'll automatically pull in these templates all underneath this project. And the templates included is widgets, which is a traditional desktop for Linux, Mac, and Windows. It doesn't support mobile or embedded, a classic desktop building template. We're going to focus more on Qt Quick and specifically Qt Quick C++ for this demo. But we also have a template for Qt Quick QML, so you can write your entire app in QML. And this is probably the best place to start if you are a web developer, because QML is based on JavaScript and uses a lot of JavaScript. So that'd be the best point of entry. So we're going to move on to the C++. We're going to choose this. We're going to take the default name and location because we don't care. Default defined build system is QMake is fine. It gives you an option to switch between 3D and 2D. We're going to click 3D, and then it gives you to kit selection. So kits is a concept by Qt, which is basically a combination of your Qt framework and your targeted platform and the compiler needed to get it there. So we have 5.15.12 and Clade 64-bit for Mac OS. We have the Clang compiler for Android, and we also have the Clang compiler for iOS. If you're on Microsoft, it would be Microsoft Visual Studio's compiler, and Linux would probably be GCC. In this case, we're just going to do desktop, and we're going to click next, finish, and then we're going to build and run a little prematurely. And you'll notice once we run this that nothing shows, and this is where that API key comes in handy. At 100.10, API keys are now required to access online maps. There's more information about API keys than I'll go into, but you get quite a bit of leeway on the free tier for API keys. So we're just going to copy this. We're going to put it in this area on main.cpp. Just look for the API key QString, put it in this QString literal, save it, build it, run it, and out of the box, all you have to do is copy and paste your API key in, and you have a fully functioning map, which is pretty nice. And now you're ready to add whatever components you want, feature layers, tables, to identify operations. Like I mentioned before, there's a whole lot of things you can do. We just kind of help you get you up and running as quick as possible. And then you have a whole backlog of samples you can pull from to help build your application.
Okay, now we're going to talk about some of the runtime fundamental patterns that you'll need to know for working with Qt. The first thing to know is that runtime is a modern asynchronous API. That means that the code does not move synchronously. You'll be able to kick off tasks that will return later at some later point in time. And so you'll have to handle that through the asynchronous programming patterns that Qt provides. Some examples of this are route task, locator task, offline map task, geoprocessing task. All these different tasks do different things, but they follow the same pattern. So it becomes very predictable. These are all loadable. So loadable is an interface that these classes all implement. Loadable means that it requires either local or online data that it needs to fetch in order to initialize. So this all happens asynchronously. They also all have async functions to execute their tasks. So route task to actually execute the route task solve, that will happen asynchronously so that other things can happen in your UI while that solves. Your UI will remain active and fluid, and you can interact with the map while it solves. For each of these, we return a type called task watcher that has a UUID and some other information so you can keep track of your concurrent tasks. In Qt, asynchronous programming is handled through signals and slots. Signals are equivalent to an event. A slot is equivalent to an event handler. Slots can either be defined as standalone methods or they can be inline Lambda functions. So it depends. If you just want to define an anonymous function on the fly, Lambda is great. If you're going to have a slot that's going to be called from multiple different places, it would make sense to set that up as a standalone method. So let's take a look at some documentation here. We've got a locator task. So locator task is used for geocoding. Geocoding, of course, is taking an address and getting real-world coordinates from that address. So you can see here the locator task has a geocode function. It takes in some text and it returns a task watcher. So it's not going to return the result right away because it's asynchronous. It's going to kick off the task and return a watcher. Then you'll see later in the documentation we have a section called signals. And under signals we have a geocode completed signal. This passes through a task ID as well as geocode results. So basically what happens here is you kick off the geocode. At some point it will emit the signal geocode completed. You can check the task ID through the task watcher to make sure everything matches up, and then you can go through your results and display them on a map. Going back to how I said it's very predictable, all of these tasks are similar, we can look here at the route task. You can see the route task also has an asynchronous function on it called solve route. Just like locator task, it has an async function and it returns a task watcher. And then we have some signals that are returned. In this case, we have solve route completed. Solve route completed also passes through a task ID, which you can get from the task watcher, and you get a result. With that result, you could then display your resulting directions on the map. So next we're going to have Jared go into asynchronous coding with Qt through a demonstration.
So yeah, we're going to do some asynchronous coding here. In this simple application, we're going to show how to use the World Geocode server to look up an address asynchronously. So first, we have some properties set for ourselves to be used later on, the geocode service URL, and then a geocode result. Every template has you started off with a map view and a map, or if you choose the 3D option, you have a scene view. In this case, we're just doing the map view, and we're going to add a graphics overlay to it. Graphics overlays, kind of described in its name, are used to display graphics in a map view or a scene view. We're going to add a graphic for the result graphic for the geocoded location, and we're also going to add a text graphic with a text symbol to display the label of that geocoded location. We have not assigned them a geometry yet, but once we get that geocode result, we'll assign the geometry of these graphics. Next, we're going to move on to the locator task itself. We need to set the URL property of this locator task to the geocode service URL, which we defined above. And then within the onGeocode status changed handler, we're going to do some work. So we're going to wait until the geocode status property of the locator task is completed. And once that is completed, we will set the first result from the geocode results to our result property that we defined above. We will take the extent of that result, set it to the map view's viewpoint, and then we will set the display location to the result graphic and the text graphic. So it is displayed in the right location, and then we will take the label from that geocoded result and set it to the text symbol. So we're going to follow this here quickly, take a quick look at the documentation for this. And as we can see with the geocode result, we have the display location, which is a point which we're using, the extent, which which is an envelope, which we're also using to set our viewpoint. We also have an input location, a label, route location, and a score. And the score we will touch on in just a moment. So let's go back to the handler. And like Lucas had mentioned before, we have these event handlers, single slots, and this is where the work is done asynchronously. So once this locator task, once this geocode task is kicked off, this will be done asynchronously in the background, and once it's completed, it'll complete all this work. So we're going to continue going forward. We're going to declare geocode parameters. We're going to give it an ID so we can use it in our geocode operation, and then we're going to set a min score for the geocode parameters. Typically, what's considered a good match is between 85 and 99. We're going to set the threshold a little bit lower for our case. And yeah, that's all we're going to do for that. And then we're going to define some user interface stuff with a rectangle and a button and a text field. Most of this doesn't really matter. The part I really want to focus on is we have our text field, which we're going to give some placeholder text just for ESRI to give us a default search if we don't want to type anything in. And then we have a button, which will do our geocode with parameters. So this is where we execute our locator task geocode with parameters. We're going to check, like I said, to see if we have any text inputted. If we don't, we'll use the placeholder text as a default. And then this will be done asynchronously. So we're going to save this, build and run. The map will load. And then we're going to take just the default. And there we go. Just a simple, useful application that highlights asynchronous coding.
So the next topic in the runtime fundamentals section is talking about memory management. C++ is not a memory managed language. What this means is that memory is not automatically handled for you. Some of the pros of this are that you're very close to the metal, as they say. You can really fine-tune performance. It's fast. You can run on memory-constrained devices. The cons are that there's a little extra work for you. So with memory management, Qt handles this primarily with the parent-child relationship. So how this works is you create a new object and you pass in a parent object. When the parent object is deleted, the children are as well. You can pass in any Q object as a parent. You'll often see the keyword this specified when you're creating a new object. Basically what that means is that the application is taking ownership of the object and it will retain its lifetime as long as the application does. The key takeaways are that any object you create on the heap, it's up to you to manage. But any object that we create internally and return to you, it always has a parent set already. You can optionally change it, but it won't leak out of the box. It will have a parent. So here's some basic code that shows setting a parent. We have a hello world application. It's subclassing QObject. And then on line 7, we're creating a new graphic saying with the syntax new graphic, and you'll see the parameter that we're passing in here. This means that the hello world application is now the parent object of the graphic. Once hello world is destroyed, the graphic will be destroyed as well. So that's great. Using this works, but in a lot of cases, you'll want to actually remove graphics and things like that as you go. So apps with lots of temporary graphics are added and removed. You don't want that memory allocated for the lifetime of the application. Another case would be when we have signals that are passing through pointers as results. The parent object, like I mentioned previously, is set by our API, so there's no leaks technically, but memory will grow each time. So there's many different ways to handle these two different scenarios. RAII is an acronym for Resource Acquisition is Initialization. There's many different ways to use RAII techniques, one of them being smart pointers with C++11. So here's an example. I have a map view, and we have an identify graphics overlay completed signal. So in this example, I want to click on the map, which has graphics. I want to identify which graphic I clicked on. That will emit this signal. You can see there's two parameters passed through, a UUID and identify graphics overlay result, which is a pointer. This means, like I mentioned, that it does have a parent set. It would be the map view in this case. But until the map view gets destroyed, those results are not going to get destroyed. And this can result in increased memory usage over time. So in this case, what I'm going to do is create a unique pointer so that when this goes out of scope and there's no more references, this will actually be deleted for me. So this is making use of C++11 unique pointers. Let's talk about memory management in QML. This is a joke, of course, because QML is a garbage collected language. You don't have to manage anything on your own. So when you are done using anything, it goes out of scope, there's no more references to it, it will automatically be garbage collected for you. So next, we're going to have Jared walk through a demonstration of C++ memory management.
So here we're going to do a different approach besides using C++11 smart pointers for memory management, and we're going to assign it a parent, a QScope pointer of QObject type for our graphic parent. And we're going to show quite an exaggerated example of what happens if you set the context to this application versus using a parent for the graphics parent when we create it. So we have our UI just has three different buttons. One adds them the bad way, one adds them the good way, and then one to clear graphics. So let's take a look at our source file. And we're going to look at the add graphics good first. So if we look at add graphics good, what we're doing is we're reverse setting the viewpoint just so we can be centered over our 0, 0, no island. We have a simple marker symbol, which is defined in the constructor. It's just a simple marker symbol. We give it diamond a color. So what we're going to do here is we're actually going to assign each graphic that we create the mgraphic parent, the QScope pointer that we defined in our header file. So why we do this is so when we inevitably go to clear the graphics off the screen, when we reset that parent with the parent-child relationship, it'll clear up. It will clear and it will take care of the graphics that were created. Clearing the graphics from the graphics list model will not release these graphics, even though they won't be displayed anymore. It won't release them if you use this context. So we need to make sure that we reset the parent and it will clear up the graphics for us. So in this case, we're adding 10,000 to try and do an exaggerated case. And then we have the bad way of doing it, which is if you use this context. In some cases, it's okay. If you only plan on adding a few graphics and you're not doing adding and removing graphics dynamically, this really isn't a problem. But if you are doing dynamic adding and removing of graphics where you clear them and then add them, and you use this context, the context of the sample, then they will last the lifetime of the sample, like Lucas had mentioned. So this will just keep growing and eating more memory. So let's run this. Oops. Let's do that. We're gonna keep an eye on our application here in the activity monitor. So first we're going to do the good method. This way uses the RAII technique of assigning it a parent, which we could reset the parent. We could optionally also go through and delete every single graphic from the list model of graphics, but it's kind of a lot of extra code and a lot of manual deleting, and you can make mistakes. It'd be easier, and it's a better practice to either use smart pointers like Lucas had shown, or in this case, assigning a parent. And then once you just reset the parent with the parent-child relationship, which is really convenient with the Qt framework, it just clears it all up for you. So we're going to add a couple clicks. It only looks like 1 point, but probably over 100,000 with how many clicks we've done now. And we see the memory climbs to 400. But once we clear these graphics, all that memory is released again, and it goes back down. So we're not constantly taking that memory on the stack. But if we add graphics and we use this context, we'll continue to eat memory like we did before. But once we go to clear these graphics, just because they've been removed from our view, we've not been given that memory back. So if you do this constantly, eventually you're going to run out of heap space.
So the final topic that we're going to talk about for key runtime fundamentals is list models. List models are Qt's way of doing MVC or MVVM. MVC standing for Model View Controller, MVVM is Model View View Model. So these are concepts to separate your business logic that are used very commonly in different applications. So in runtime, any mutable list of objects is exposed as a list model in the Qt Runtime API. So for example, a layer list model, a graphic list model. As an example, map contains a list of layers. You can add layers, you can remove layers, so it's mutable. And on the right side here, you can see we've got an example of a layer list control. We've got a toggle, a checkbox to toggle the visibility, and then we've got the name of the layer. List models can be plugged in to work directly with list views, table views, and grid views. So Qt exposes many different view types, and you can simply provide the model and display the data in the view with very little coding. So the model in this case is the data. Like I mentioned, it would be, in the case of maps and layers, it's those layers in the map, that's the data. And we have the view, so what is actually displayed. On the right hand side here, we have a list view. And then we have a delegate. The delegate accesses the individual items' roles. So we'll get into that in the next slide. So let's take a look at the map API documentation. Here you can see we have a getter called operational layers on the map, and that returns a layer list model. When we go to the layer list model documentation, you can see we have a layer list model, and it inherits QAbstract list model. So QAbstract list model is the standard type that Qt exposes for you to create your own list models. So any list model in Qt will be created from a QAbstract list model. When you look at the layer list model documentation, you'll see a list of roles. So here we've got, the layer has a name, it has a description, has visibility. All of these components of each individual layer in that list are exposed and can be accessed from the delegate. So let's look at some code. In this case, we've got a list view. So that's our view. We've got the model, where here we're using property binding like I talked about earlier. So you have model : map.operational layers. So you're binding to the map's operational layers. If the map's operational layers ever changes, then we'll update automatically because of property binding. And then finally, we have the delegate. The delegate defines the individual components in that list view. So in this case, we're just going to simply write the name out, the name of the layer. So that's accessing the name role. So next, we're going to have Jared go through a little bit more of an advanced use case for working with list models and show the real power of list models.
So yeah, we're going to build off a previous application from the third demo, which was the searching for an address for the asynchronous coding. And we're going to build off of that and display a suggest list model from suggestions based on what we're typing. So the first thing that we're going to want to add in here is the suggest parameters. I have this defined. I'm going to copy and paste this over. So for the suggest parameters, we're going to give it some categories to suggest: address, points of interest, populated place, and then set a max results just so it's not taking up the entire screen. And then once we've declared the suggest parameters, we're going to go back into our locator task and set the suggest parameters for the suggestions list model within this locator task right here. And then after that, we are going to declare a list view to display our suggestion list model. Copy and paste this over. We're going to add that right here. So this list view takes a model, which is going to be our suggest list model from our locator task. And then for each item within that model, we're going to have a delegate. And within that delegate, we're going to have a component, which is going to display a rectangle filled with, which contains text. And then we're going to use the role from the list model, which we should go take a quick look at. List models have roles. In this case, we only have one role defined within the suggest list model, and it's label. So we're going to use that label, which is a Q string, and we are going to display that in the text. So let's close that. And yeah, that's all I want to talk about with that. And then the last thing we need to do is we need to decide on when we want to display these suggestions. And for this use case, we're going to do it every time the text field has any change to the inputted text. Anytime the text changes, we want to display the suggestions. So it's very dynamic. And so people, when they're trying to figure out what they want to search, they're just automatically giving them suggestions to help complete that. So we're going to save, build, run. And then, like we did before, we can just geocode the default result. We have ESRI, or we could do something as simple as, and then as you can see here, this is actually our list model being displayed in the list view dynamically. And as you keep typing, it gives you more and more suggestions. And then you can click on one of these and it'll pull it in, and you click on geocode and geocode that result. Yeah, it just shows you how useful list models can be, in that you can bind to it you can bind to the property of the locator's task list model and just give you results as you're doing it. But it just kind of shows how useful list models can be, and there's lots of applications for them.
Okay, so let's wrap everything up. First, I want to close out the talk by sharing how ESRI uses Qt. So of course we have the Runtime SDK for Qt, which is the product that we're demonstrating here. But we also have App Studio for ArcGIS. This is a tool you might have heard of. It helps you build native applications very quickly with no coding at all. So they have templates that will help you create native applications without writing any code. You can take those, further customize them by writing your own code, or you can just build applications from scratch. They even have Survey 123 and Quick Capture built on top of App Studio. They expose the source code for Survey 123 right through App Studio, so you can actually take Survey 123 and customize it further by writing QML and Qt code. So this is a really cool tool to help you build applications quickly. We also use Qt internally for testing Runtime Core. So all of the Runtime SDKs are built on top of a common C++ core. Because this is written in C++, we can use Qt to test at the core level. So this has become really a useful tool for us. So this is all just to say ESRI's investing heavily in Qt. We find that it works very well for us for running all of these different applications on all the different platforms that we need to support. So what SDK resources are available to you? So the Runtime SDK is an SDK. It's not just an API of functionality. There's many different components to the SDK to help you be successful. So the first thing I want to talk about is the developer site. This is completely redesigned. If you go to developers.arcgis.com, you'll see lots of new improvements. We've got lots of conceptual documentation with snippets. We've got tutorials, many new tutorials to help you get started with some of the more basic workflows. We've also got our API reference up there, so you can see all the different members of every single class that we have. We've also got a sample project. So this is an open source repo on GitHub. We've got very basic sample applications, and we've got very advanced sample applications. All these are available to clone, and we also have a viewer application that pulls all of these samples together into one. This viewer application is downloadable via ArcGIS Online. I think at this point we have somewhere around 200 samples for each QML and C++, so we have a lot of different workflows covered through the samples. We also have a toolkit. So the toolkit is available on github.com. It's an open source repo. This basically provides you ready to use UI components. So an example would be north arrow. Many different applications are going to need a north arrow. So instead of you having to code it up yourself, you can just simply bring in the north arrow we've already created, and everything is just ready to go and works for you. Finally, we've got the DSA open source app. So DSA stands for Dynamic Situational Awareness. We built this application to show how you would build a real-world, fully functional application. It does things like show your location, show the location of your teammates in the field. It's real time, so you can see them as they move around. You can create rules, like I want to be alerted when teammate A enters some new area. So all of these capabilities are showcased along with the patterns that we recommend for implementing this in this open source repo. So just to reiterate, how do you get started from here? Create a developer account, download the Qt framework and the Runtime SDK, complete the tutorials, clone the sample repo and build, run, and modify the samples, and then use the forum GeoNet and join the community discussion. If you have any questions on this topic at all, we'd love to be able to help you. So just post your question right on GeoNet. Jared and I would like to thank you for listening and have a great rest of your Dev Summit.
All right. Thanks everyone for listening. We've got a few questions rolling in. We'd welcome you to add any additional questions that you have in the Q&A portion. So the first question we have here is, what are the differences or limitations when we compare App Studio for ArcGIS and ArcGIS Runtime SDK for Qt? Jared, you want to take that one?
Yeah, sure, Lucas. That's a good question. So yeah, the Runtime QML API is included with App Studio, so it is directly packaged within it, and you have the full access to the QML API with no limitations.
All right. Okay, next question. Do I need to purchase a Qt license? So I mentioned it, I kind of glossed over it quickly. Qt's a dual licensed product, so it's both open source under LGPL, and it's a commercially licensed product. It's managed by a company called the Qt Company. So I can't give you a definitive answer. It depends on the modules you use, whether you're statically linking or dynamically linking, whether you can fulfill the LGPL v3 license requirements. All of that basically depends. So there are two different options, but there's stipulations, you know, with open source. All right. So we've got another one here. Do you support Qt 6? All right, Qt 6. So right now our API is based off of Qt 5. So I believe in December of last year, Qt released the first version of Qt 6. It's the next generation of Qt. We currently do not support Qt 6. We're looking at how we can support it going forward, especially once the first LTS is out, which is 6.2. That comes out later this year. But we're still waiting on some modules for us to be able to even build the API. Some things like positioning and multimedia, some requirements of us to even build are not there yet. So we're a little bit of ways out from supporting it, but it's really going to be driven based on what the customer demand is. So we want to hear from you. Reach out to us on GeoNet. We want to know if this is something you need or if you'd prefer to stick with Qt 5. So yeah, that's our position on Qt 6 right now. Okay. Looks like we do not have any more questions queued up. So with that, on behalf of Jared and myself and ESRI, we'd like to thank you all for joining us. Reach out to us on GeoNet. We'd like to see what you're up to, help you out with any questions you have after this, and have a great rest of your developer summit. Thank you.